Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos. Lesson 2. Acids, bases and salts. Acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. Litmus is a natural indicator. Turmeric is another such indicator. You can also use synthetic indicators such as methyl orange and phenol phthalate to test for acids and bases. Understanding the chemical properties of acids and bases. Acids and bases in the laboratory. These indicators tell us whether a substance is acidic or basic by change in color. There are some substances whose odor changes in acidic or basic media. These are called olfactory indicators. Reactions with acids. 1. Reaction of acid with metal. Acid plus metal, right pointing arrow, salt plus hydrogen gas. Mg plus H2SO4. Formed H2 plus MgSO4. 2. Reaction of acid with carbonates. Na2CO3 plus 2HCl formed 2NaCl plus H2O plus CO2. 3. Reaction of acid with bicarbonates. NaHCO3 plus HCl formed NaCl plus H2O plus CO2. Similarity between acids and bases. Both acids and base react with water. They produce ions in water. Both acids and bases act as electrolytes, so are good conductors of electricity. Both of them change the color of the litmus paper. Classification of acids. Acids are classified as organic acids and mineral acids. Acids which are derived from plants and animals, they are known as organic acids. For example, citric acid from fruit. Mineral acids are inorganic acids such as sulfuric acid. They are dangerous to be used, so need more precautions. Acids are also classified as strong acids or weak acids. Strong acid is an acid that completely dissociates into ions in aqueous solutions. For example, sulfuric acid, hydrochloric acid. HCl acid. H2O equals H3O plus Cl minus. Weak acid is the one which does not dissociate completely into ions in aqueous solutions. For example, acetic acid. CH3COOH plus H2O. CH3COO minus plus H plus. Acids can also be as dilute acid and concentrated acids. The one which has low concentration of acids in aqueous solution, they are known as dilute acids, whereas the one which has high concentration of acids in aqueous solution are known as concentrated acids. It is advisable to add acid to water and not vice versa because large amount of heat is released if water is added to acid. This released heat is large enough to cause harm. Acids can also be classified based on number of hydrogen ions. Monoprotic acid is the one which gives 1 mole of hydrogen ions per mole of acid, such as HCl. Diprotic acid is the one which produces 2 mole of hydrogen ions per mole of acid. For example, H2SO4. Bases. Bases are the one which produces hydroxide ions in aqueous solutions. Bases which are water-soluble, they are known as alkalis. They turn red litmus to blue. They have a bitter taste. They also produced carbon dioxide when reacted with carbonates. They also evolved hydrogen gas when bases react with metals. Reactions of bases. 1. Reaction with metals. Base reacts with metals and produce hydrogen gas. 2. NaOH plus Zn equals Na2 equals Na2 ZnO2 plus H2. 2. Reaction with acids. Base reacts with acids to form salts. For example, KOH plus HCl equals KCl plus H2O. 3. Reaction with non-metallic oxides. Base reacts with non-metallic oxides to form salt and water. 2. NaOH plus CO2 equals CO2 equals Na2CO3 plus H2O. Classification of bases. Bases are classified as strong base and weak base. Strong base is the one which dissociates completely into its ions in aqueous solution. For example, NaOH weak base is the one which does not dissociate completely into its ions in aqueous solutions. For example, ammonium hydroxide, NH4OH. Bases are also classified as dilute base and concentrated base. The solution which has low concentration of base in aqueous solution is defined as dilute base, whereas the one which has high concentration of base in aqueous solution is known as concentrated base. Strength of acid or base solutions. The dissociation constant of weak acid or weak base can be represented as CH3COOH plus H2O, CH2COO minus plus H3O plus NH3 plus H2O, NH4 plus OH minus. Suppose HAR is weak acid, then dissociation constant is represented as HA plus H2O, A minus plus H3O plus K equals H3O plus A minus upon HA. Strength of an acid or base can be determined using a pH scale. It is a scale to measure the hydrogen ion concentration in a solution. The P stands for potens. It is a German word which means power. If pH is equal to 7, means the solution is neutral. If pH is greater than 7, means alkaline solution. If pH is less than 7, means the solution is acidic. Importance of pH. Human body works at a pH of about 7.4. Stomach has a pH of about 2 due to presence of hydrochloric acid in it. It is needed for the activation of pepsin protein required for protein digestion. When we eat food containing sugar, then the bacteria present in our mouth break down the sugar to form acids. This acid lowers the pH in the mouth. Tooth decay starts when the pH of acid formed in the mouth falls below 5.5. This is because then the acid becomes strong enough to attack the enamel of our teeth and corrode it. This sets in tooth decay. The best way to prevent tooth decay is to clean the mouth thoroughly after eating food. Many animals and plants protect themselves from enemies by injecting painful and irritating acids and bases into their skin. When honeybee stings a person, it injects an acidic liquid into the skin. Rubbing with mild base like baking soda solution on the stung area of the skin gives relief. When a wasp stings, it injects an alkaline liquid into the skin. Then rubbing with a mild acid like vinegar on the stung area of the skin gives relief. Soil pH and plant growth. Most of the plants grow best when the pH of the soil is close to 7. If the soil is too acidic or basic, the plants grow badly or do not grow at all. The soil pH is also affected by the use of chemical fertilizers in the field. Chemicals can be added to soil to adjust its pH and make it suitable for growing plants. If the soil is too acidic, then it is treated with materials like quicklime or slaked lime. If the soil is too alkaline, then alkalinity can be reduced by adding decaying organic matter. Salts. When acid and base neutralize, salts are formed. Strong acid and strong base combines to form neutral salt. NaOH plus HCl equals NaCl plus H2O. Strong acid and weak base combine to form acidic salt. For example, hydrochloric acid and ammonium hydroxide combine to form ammonium chloride. Other examples: sodium hydrogen carbonate, sodium hydrogen sulfate etc. HCl plus NH4OH equals NH4Cl plus H2O. Similarly, weak acid and strong base combine to form basic salt. For example, acetic acid and sodium hydroxide combine to form sodium acetate. Other examples are calcium carbonate, potassium cyanide etc. CH3COOH plus NaOH equals CH3COONA plus H2O. The most common salt is table salt or sodium chloride, NaCl. Indicators. They are the substances which indicate acidic or basic nature of the solution using color change. For example, litmus solution, methyl orange, phenol phthalate, methyl red etc. Acids convert blue litmus paper red in color. Bases turn red litmus blue. Phenol phthalate remains colorless in presence of acids but turn pink in presence of bases.